Hello everyone, my name is Rick Malava and this is going to be a how-to video for simplymaya.com. One of the users on the site, Silverfeather, wants to create this effect here, and he wants to create this helical shape that goes in an elliptical path around this central sphere here. And Maya has a helix preset, but it's hard to get it to follow a specific path. You could create a helical strand, a pair of helical strands, to get them to form this helix, this double helix, and then take a bend modifier and create a circular path with the two helical strands, and then connect them up, merge the vertexes at the end, and then to create the oval shape you'd have to scale it, which would then start to stretch things. So I was recently working on a project and I had to create a pair of twisted wires that follows a path, and the technique I used is something that I developed when I was using a spline based package some years ago. And the way that I do this is I would take a spline path that defines the path that I want to have the twisted wires follow, and then I extrude a rectangular shape along this path, and as I extrude the rectangular spline along the path, I rotate it. Now you can do the same thing in Maya, but instead of splines and a spline rectangle, you use a NURBS curve and a polygon face that you then extrude along the NURBS curve and twist that polygon face as it goes along, and then you can pull two edges off of the surface that gets created, and now you'll have a twisted NURBS curve network that follows the path that you've defined. So let's look at how we can do that, and we'll actually create this elliptical shape for Silverfeather. Okay, so let's get to the process of creating this shape here for Silverfeather. So I'm going to jump into Maya, and here you can see an example of the twisted wire, the twisted safety wire from the 50 caliber machine gun project I was working on. And if I hide these surfaces, wow. All right, let's try that again. 1, 2, 3, hide. Yay. Okay, I win. Here we go. So you can see what I've got here is a path. And then what I did was I took a rectangle and I extruded it along this path, or polygon face. I extruded along this path. And then using the twist attribute of the extrude node, I twisted that surface and it created a twisted surface along the path. And then I just extracted two of the curves from the surface that I extruded along the path, and I left with a pair of NURBS curves that twist around each other and follow this path. And then all that's left to do is to extrude a profile curve along these curves to create the effect of the twisted wires. So let's hide that, and let's do this elliptical path with a pair of twisted curves that follow it. So I'm going to start by creating a NURBS circle. And I'm going to take that circle and I'm going to scale it to make a sort of an orbital path, an elliptical path. And then I want to make sure that I have enough CVs in this NURBS curve here so that I can get the resolution I need when I create the twisted set of CV curves that go around it. So what I'm going to do is rebuild this curve, and you can rebuild the curve by going to Edit and Rebuild Curve, or I have it on my, you want to go to Rebuild Curve Options, and I have it on my shelf here. And I'm going to rebuild this curve to be uniform. I'm going to have it go from 0 to spans. I'm going to have it maintain the tangents around the curve, and I'm going to add 100 CVs. So I have an option turned on that displays the knots in my surfaces, so you can see I have 100 CVs around here. Now it seems like a lot, but you'll see the purpose of that as we go along here. If you make this too sparse, you're going to have a problem when you try to extrude a profile along the twisted curve that we're going to create here and keep it perpendicular to the curve. So the next thing I need to do in this process is find out where the start and end of this curve is. So you do that by going holding down the right mouse button, go to Control Vertices, and you're going to look for a box and a U. And the direction of this curve, the curve starts at the box and goes in the direction of the U. So this curve, this NURBS curve starts here and goes in this direction all the way around. And it's important to know where this thing starts and ends for a closed surface like this. In order to get an extrude that goes the entire path around the closed surface, you have to put your initial profile curve at the UCV. So I'm going to create now a polygon cube right here. And all I need off of this cube is one face. So I'm going to delete all the other faces. And then I'm going to pick this guy, I'm going to center its pivot, and I'm going to snap it by holding the V key down and the middle mouse button to that U vertex right there. Okay, just to make sure, we'll go to CVs again and you can see that it's on the U vertex. Okay, so now I'm going to take this polygon face and I'm going to extrude it around this path by selecting the profile curve and the path, and then I'm going to go to extrude, which I also have on my shelf bar, but you can get to by holding down edit mesh extrude right here. So I'm going to extrude it, and when you extrude it, it's going to do something strange like this. Now the reason for this is when you do an extrude of a polyface, it just creates it with one segment that goes from the starting point to the ending point, and since those are one and the same, it gets all kind of wonky looking like this. But don't panic, go to the extrude node in your channel box and look for the division attribute, and just make that division attribute equal to the same number of divisions that we put into the NURBS curve, which is 100. This ensures that every segment of the surface that we create here lands on top of a CV. If I go to the top view and go to wireframe, you'll see that every section here now is equal in size because I created a uniform curve, and each section lands on top of a CD. Now this is really important. Listen close here. If I had created this surface here with a greater number of divisions or a smaller number of divisions than I had in the NURBS curve that I used to extrude it along, Maya would decide how big each of these sections should be. And what would happen is it will create the sections in this area where the curvature is greater, they'd be closer together, and where the curvature is farther apart or less curved, they would be more spread out. So by making sure that you set your divisions, first of all creating your CV curve uniformly, and then using the same number of divisions as your CV curve, you'll match up the sections with the CVs every time. So now our objective here is to create a twisted pair of curves that we can create a helical, a double helix shape off of. So to do that, the next step would be to grab an edge loop on this surface that we just created that follows our path, and then go to create, go to modify, convert polygon edge to curve, and that creates a NURBS curve that follows that path. And so if I come down to this edge down here and I select this edge loop and hit the G key, I now have a NURBS curve that is following that path. And if I hide the surface quickly, you see now I have the original path and I have two curves. Now the trick is just to make those curves twist in a double helix that goes around this this path curve. And to do that, I'll bring back the surface here just so you can see it more clearly. If I go back to that extrude node, and just below the division attribute, you'll see twist. And if I type 360 in here, you see what happens is as that polygon face gets extruded around that path, it's twisted one full revolution. So I've now twisted the curves, because I have history that I selected, also one full revolution. And so if I hide this surface again, well, I'll keep it visible here for a second. If I come back into its extrude node and I increase this twist value in multiples of 360, right now I have two full revolutions as it goes around. And if I make it 1440, I have 4 revolutions. And if I make it 2880, I have 8 revolutions as it goes around that path. And now if I hide the surface, you see I have a double helical shape that follows the exact path that I'm interested in. And so now all that's left is to create a profile curve and sweep it along these two paths, these two helical paths. So I'll go over here and I'm going to create a NURBS circle at the origin. I'll make it that big. And before I sweep it along these paths, though, there's a little housekeeping I have to do. This path, if you look closely here, has two knots at this end. It's not a closed path. To make this a closed path, I'm going to hold the Shift key down and the right mouse button, go to Open Close Curve, Options, make sure the Blend Radio button is selected, and when I hit Apply, watch, this section here will smooth out. Well, first what I'm going to do is show you in the attributes that it says the curve is open. So when I hit Apply, once again, watch where they connect up there. See, it smooths out. And now if I go back to the attributes for this curve, you see it says now it's periodic. So same thing down here. I select this curve, it's open. If I hit Apply, you see it smooths out. And now if I select this again, you see it's periodic. So now I have two closed paths. And so now all that's left is to take the profile and the path, come down here to Surfaces, and do an extrude. Go to its options. By default, these will be the settings. And then what you want to do is make sure that you extrude your profile along the path, or you want to make a tube. You want to extrude it along the path. You want to use the component mode, which will take the local axis of your profile and sweep it along the path. And then you want to make sure that your profile curve is perpendicular to the path. And this, once again, is why we had to create the reason I created these NURBS curves with the density that I did. The way that the profile normal is computed is it looks at one knot to the next, and it keeps the profile curve perpendicular to that vector. If the number of CVs is too sparse, what will happen is the profile curve won't be really perpendicular at each knot, and so you won't get a perfect circular profile along the path. But you don't want to make the number of CVs so great that it gets so dense that you either increase the density of your model unnecessarily, or you make it too hard to manage. So you have to kind of shoot for something in between. So let's apply that. All right, and that's looking kind of thick, so this has history. So I can come in here and select the profile curve again and hit R, and I can say I want it to be a little thinner. Right, now don't worry, this happens sometimes and sometimes it doesn't. I'm noticing that at my start point, the original profile here gets squished down. This happens sometimes. It's easy to fix. We just come in here and select the affected CVs and just scale them back out. Okay, so that's fixed. Now let's do it for this curve. So we'll select the profile again and the curve and create our helix. And then once again, just come in here, select control vertices, and scale those out to fix that little problem at the end there. Now the beauty of this method is not only have we created this double helix now that follows the exact path that we want, and it's not squished or stretched because we had to scale it after the fact, but we can also come in here now and because it has history, I can select the polygon face that we originally used to create the helical paths, and I can go back to its history of the extrude node. I can come down here and I can actually change the twist. Say I can increase it, double it from here, and say what is one double 4? It's 14, 40, 28. This will be what, 57, 70? 70. Boom. And there you go. We've actually increased the how tightly wound the coil is on the fly, so you can change it after the fact, which is really nice. And the only thing you have to be aware of is whenever you do that, sometimes you may have to come back in and just tweak the starting the CVs at the start end of the surface that gets created. In this case, it was fine. Like I said, sometimes it'll get squeezed or stretched, and you just come in and have to just change that one hull. So it's that'll always be the case. Now, the only thing you can't do with history, unfortunately, using this method, is I can't take the original path here and move it. If I try to move it, you see the beginning and end gets messed up, and that's because Maya's NURBS tools haven't been updated in a long time, and it has to do with double translations. And Maya's NURBS toolset could really use an overhaul. I don't think they've been touched for all the way back. I've been using Maya since 1998, and I don't think the NURBS tools have changed significantly since then. So I'm hoping Autodesk one day will come back and fix some of the node history stuff and some of the NURBS tools. But anyway, this is I think a useful technique. Like I said, I can come in here and just very briefly, I'll select this profile curve again, and we've got a double helix now. If I was to stretch this profile curve, now I've got a twisted pair of wires like I did in the safety wire example. If I pulled more than two edges off of the original profile curve, I could have a rope or a cable here instead of just a twisted pair of wires. So you can create any kind of a twisted surface that follows a specific path. So that's it. I hope this is a useful technique. I hope it helps you out, Silver Feather, and I hope anybody else that needs to create a twisted pair of wires in Maya will find this helpful. Thanks a lot for watching, guys.